Hey, today we are on pages 7 and 8, and we are going to talk about surface area of rectangular prisms. So, surface area is the total coverings on the faces of a three-dimensional shape. So I like to think about if we are wrapping a present, how much wrapping paper do we need? If we're making a cardboard box, how much cardboard we need? We basically figure out how much on the outside that we need. So we have this shape. It's a 3D shape. It's a rectangular prism. Okay. And we basically unfolded it like if it was carpet. And we are going to basically figure out how much cardboard we would need. So what we first need to do is we need to understand what the dimensions of all of these sides are. Okay. So we have A, B, C, D, E, and F. Okay. So E and F are the same. Those would be our bases. Okay. So B for bases. Okay, and if I look for the dimensions of the bases, I see a 4 by 3. Okay. Okay, then we have two different sides. We have the front side. So the front side looks like it is 4 centimeters by 11 centimeters. Okay, and then the other one is a little bit shorter. It's a 3 by 11. So I'm going to put these longer ones, I'm going to say that they're 4 by 11. Okay, that means that this would also be 4 by 11. And these shorter ones would be our 3 by 11 sides. Okay, now what we can do is we can use our information to find the area of every single rectangle. So we're just going to start at the top. We have a 3 by 11 rectangle. So 3 times 11 is 33 square centimeters. Okay, then we have a bigger one. We have this we have the front one, which is a 4 by 11, which is 44 square centimeters. Okay, and then we have the left-hand side, which would also be a 3 by 11, which would be another 33 square centimeters. And then we would have the back side, which would be another 4 by 11. Okay. Then finally, we have the top and the bottom are our bases. So we have a 4 by 3, which would be 12 square centimeters, and then we would have the top, which would be another 12 square centimeters. Then what we would have to do is we would have to find the sum of all 6 of these. So we are going to add together 33, 44, and 12. And we would have 2 of those, so we could double it, and we would get 178 square centimeters needed for this shape. Okay, so the total surface area is the total area of all 6 faces. So rectangles are pretty cool because you have a front and a back, which would be the same size. You'd have the left and the right, which is the same size, and you have the top and the bottom, which would also be the same size. Okay, so that's what we're going to do. We're going to, we have this net, okay, and we have different congruent figures. We have different size shapes that are the same size, and we're going to find the area of each figure. Okay, so let's start off with this big one. Okay, so we know that it is 15 meters long, and if we use our deduction skills, this would have to be 8 meters long. Okay, so we are going to find the area, so that'd be 8 times 15. So 8 times 15, which would be 120 square meters. Okay, but we also have another one that's the exact same shape. So we would have 2 of them. So we're going to double that, and we get 240 square meters for those 2 sides. Okay, so now let's pick another shape. Okay, so let's pick the skinnier one. Okay, so this one is still 15 meters long. Okay, but now we have to figure out how wide this rectangle is. Well, we used 8 for that one, so I think it has to be 6 meters. Okay, so we're going to do 15 times 6, and we get 90 square meters. But we have another one that's the exact same shape and size, so we are going to double that, and we get 180 square meters for the purple one. Okay. Finally, we have these little bases, okay, and it says that it's a 6 by 8. So we'll do 6 times 8, and we'll get 48 square meters. Again, we have 2 of them because we have the top and the bottom, so we're going to double that. So 48 times 2, and we get 96 square meters. And then to find the total, we would add all of our areas together. So we would add 240 plus 180 plus 96, and we would get 516 total square meters needed to cover this shape. All right, on page 8. Next, we're going to talk about lateral surface area. And that is the covering of the surface of the solids except for the bases. So this would be like if you were covering a soup can. Soup can goes around a can, but it doesn't cover the top and the bottom, okay? So we will get to cylinders later, but we're basically just not going to add the bases to it, okay? So this one, we're gonna find the lateral surface area, okay? Which means not the bases. These would be our bases, so we are not going to calculate those. Okay, so we have a 5 centimeter by 4.2 centimeter rectangle, so 5 times 4.2, and we get 21 square centimeters. Okay. I noticed that this would be the exact same, so we also would have another 21 square centimeters. Okay. Then we have to figure out the other one, right? So I know that this would be 5 centimeters, and using my deduction skills, this would be 2.9 centimeters. So I'm going to do 5 times 2.9, and I get 14.5 square centimeters, which means this one is also 14.5 square centimeters. So then I'm going to add all 4 of those together. Again, lateral surface area means not the bases. So I'm going to do 21 plus 21 plus 14.5 plus 14.5. And I get 71 square centimeters total. All right. Now we're going to find the total surface area of this one, which means all 6 sides. All right. All of the surfaces of the cube below are painted. How many square inches will be covered? So we're talking about it's being painted, so we're thinking about area. So we're trying to figure out how much total area it is. So the cool thing about a cube is that they are all the same size. Okay, so that means this front right here is every single size is on every single side. So we have 1, 2, 3, 4, 5, and we have the bottom. So we are just going to find the area of one side, and we can just multiply it by 6. Okay, so a cube, it says that it's 4 inches. Okay, a cube means that each side is the same. So a 4 by 4 would be 16 square inches. And if we have 6 of those, 16 times 6 would be 96 square inches needed to paint this cube. All right, next we have, again, one more total surface area, and it's not decomposed for us, so we kind of have to just look at it and visualize it ourselves. Okay, so first I'm going to do the front. Okay, so the front, you see this shape right here, okay? So I see that it's 8 inches long, okay? And then if this is 2.5, this has to be 2.5. Okay, so I'm going to do 8 times 2.5, and I get 20 square inches, okay? And then I'm going to double it because if this is the front, the back would also be 20 square inches. So that would be 40 square inches for the front and the back. All right, now let's do the left and the right. Okay, so I'm going to start with the right because it looks like it kind of just shows me a little bit more. Okay, so Let's say that it is 4 inches long and 2.5 inches high. Okay, so 4 times 2.5 would be 10 square inches. Again, I need to double it because we also have the right-hand side. Okay, so that would be 20 square inches for the left and for the right. Okay. Finally, we have the top and we have the bottom. Okay. So at the bottom, I see that it's 8 inches long and it's 4 inches up. So 8 by 4 would be 32 square inches. But again, I need to double it because we also have the top of this. So that would be 64 square inches. Okay. And then after we do all that math, the last thing we have to do is find the total. So we're going to add our front and our front and our back, our left and our right, and our top and our bottom. So we're going to add 40 plus 20 plus 64, and we get a total of 124 square inches for this entire shape. All right, today we have a couple Delta math problems that we will just practice.